All right, let's look at how to balance these hydrocarbon combustion reactions. Again, take a look at, and you can easily see the three of them here. I'll just scroll down so you can see the fourth one. You'll see there's a definite pattern with hydrocarbon combustion reactions. All of the reactants have a hydrocarbon, and that is hydrogen and carbon, and stuff like propane, methane, candle wax, and this one here, C3H6, look that one up so you can get its name, all being combined with oxygen. Whenever we're talking combustion, whether it's hydrocarbon combustion or any kind of combustion, it's with oxygen. But look at the products from these reactants, same product, CO2, H2O. Now that's assuming these burn perfectly. Usually they don't, right? And there's soot, so there would be, now soot is actually, some of the carbon hasn't burned properly. And there's also never a pure atmosphere of oxygen that they're burning in, so there would also be dinitrogen monoxide or nitrous oxide would be produced, and other chemicals in the soot. But assuming these burn perfectly, this is exactly what happens. And let's start with these. We always balance the carbon first, so go with the carbon first. Then the hydrogen. Once you get those two, you see what the oxygen adds up to, because that's going to change the number of oxygen once you balance those two. And so then finally you do the oxygen at the end. And sometimes you got to change your numbers, sometimes you got to double stuff to get it right. But let's start right here, C3. We got three carbons there, only one here, so let's put a 3 there. Hydrogen next, 8. We got 2, so let's put a 4. Like I said, now that carbon and hydrogen are done and the oxygen isn't, but now we can worry about only oxygen. 3 times 2, that's 6. 4 times 1, in other words 4, so there's 10. There's 10 oxygens. Make sure you can see what I'm seeing here, that there's 10 oxygens on this side. So it's simply put a 5 and put a 1. 1 propane, 1 mole of propane, 5 moles of oxygen will give us 3 moles of CO2 and 4 moles of H2O gas, because it's so hot. And we've all started up a barbecue or seen a barbecue or attended a barbecue. Let's do methane. We got 1 carbon, 1 carbon. Hey, it's balanced. No. Do the hydrogen. 4 hydrogen, 2 here. So let's just put a 2. Now there'll be 4. Now let's worry about the oxygen. 2 oxygens plus 2 oxygens. We need 4. So stick a 2 there. 1 mole of methane, 2 moles of oxygen makes 1 mole of CO2 gas and 2 moles of water as gas or water vapor, and of course a lot of energy. This is in our furnaces in our houses, apartments, natural gas, pretty important to the Alberta economy, BC economy, down in the States, Ukraine, lots of places. This is a critical part of our industrialized nations. Okay, back to chemistry. That was social studies. Candle wax, C25H52. Yeah, if it heats up enough, it's going to become a gas. We do know this exists, obviously, as a liquid. This one's going to be a challenge. Let's see what happens with this. I almost suspect I might have to double this 25 to 50. I wonder, might not, but I'm ready to do that. I'm flexible enough. I kind of know that, yeah, sometimes the balancing, we got to change these ratios and the coefficient. All right, so let's now do the hydrogen. We've got to do 52, so let's put a 26 there. Okay, let's see how much, okay, so that again was a hydrogen, yeah, so balance the hydrogen, 26 times 2 is indeed 52. In total, our oxygens, we're going to have 50 and 26. Going to do a little bit of math here for the oxygens on this one. 250 plus 26, 76. Yeah, half of that, right? So we're just going to go 38. Yeah. Oh, I didn't have to double it. That's cool. 38. Check your calculator on that one. 38 times 2 should indeed be 76. And yes, it is. 1 mole candle wax, 38 moles of oxygen gas, going to give us 25 moles of CO2 and 26 moles of water as vapor plus energy. Hey, if we put a candle on fire, that's cool. Last one here, 3 carbons. Again, it's one. I see. I just feel that we might need to do some doubling here, but let's just go with what we're saying. So 3. Again, be comfortable enough. You know, you might have to turn this 3 into a 6, but let's start here. 3 carbons. Let's do the hydrogen. 6. So if I put a 3 there, okay. 3 times 2, that's going to be 6 oxygens. 9. Oh, yeah, I can't do that, right? That doesn't work. So, you know, be okay with doing that. You know, kind of just cross it out or just erase it. So let's double it. 6 and 6. Okay, we got 6 carbons. We got 12 hydrogens. Well, I better put a 2 here. Okay, so that actually takes care of. I got 2 times 3, 6 carbons on the left, or sorry, over here on the right. I got 6 carbons on the right. I got 6 carbons on the left. 2 times 6, that's 12 hydrogens there, 12 hydrogens there. Now we can deal with the oxygen. Okay, 6 times 2 is 12, plus 6, 18, half of 18, 9. I feel this can be simplified, but you know, if you divide everything by 2, that doesn't work. 9 doesn't divide by 2. There's no common multiple. So indeed, it is 2 moles of C3H6, 9 moles of oxygen. So burn those two together would give us 6 moles of CO2 and 6 moles of H2O gas and give off some energy. That's how to balance hydrocarbon combustion. Look this one up. Get the name for C3H6. Okay, practice these exact same ones again. Do the carbon and hydrogen first, then balance the oxygen. Take care, Science 10.